I started learning data science about 4 years ago. I had no real programming background. This is mostly geared towards people who are in the same position I was in. A lot of advice around learning data science starts with, first learn Python, or, first take a linear algebra course. This advice is fine, but if I followed it, I never would have learned any data science. 1. Learn to love data. Nobody ever talks about motivation in learning. Data science is a broad and fuzzy field, which makes it hard to learn. Really hard. Without motivation, you'll end up stopping halfway through and believing you can't do it, when the fault isn't with you, it's with the teaching. You need something that will motivate you to keep learning, even when it's 1 a.m., formulas are starting to look blurry, and you're wondering if this will be the night that neural networks finally make sense. You need something that will make you find the linkages between topics like statistics, linear algebra, and neural networks. Something that will prevent you from struggling with the, "What do I learn next?" question. My entry point to data science was predicting the stock market, although I didn't know it at the time. Some of the first programs I coded to predict the stock market involved almost no statistics. But I knew they weren't performing well, so I worked day and night to make them better. I was obsessed with improving the performance of my programs. I was obsessed with the stock market. I was learning to love data. And because I was learning to love data, I was motivated to learn anything I needed to make my programs better. Not everyone is obsessed with predicting the stock market, I know. But it's really important to find that thing that make you want to learn. It can be figuring out new and interesting things about your city, mapping all the devices on the internet, finding the real positions NBA players play, or anything else. The best thing about learning data science is that there are infinite interesting things to work on. It's all about asking questions and finding a way to get answers. Take control of your learning by tailoring it to what you want to do, not the other way around. 2. Learn by doing. Learning about neural networks, image recognition, and other cutting-edge techniques is important. But most data science doesn't involve any of it. Here are some important guidelines. 90% of your work will be data cleaning. Knowing a few algorithms really well is better than knowing a little about many algorithms. If you know linear regression, k-means clustering, and logistic regression really well, can explain and interpret their results, and can actually complete a data project from start to finish with them, you'll be much more employable than if you know every single algorithm, but can't use them. Most of the time, when you use an algorithm, it will be a version from a library, you'll rarely be coding your own SVM implementations, it takes too long. What all of this means is that the best way to learn is to work on projects. By working on projects, you gain skills that are immediately applicable and useful. You also have a nice way to build a portfolio. One technique to start projects is to find a dataset you like. Answer an interesting question about it. Rinse and repeat. Here are some good places to find datasets to get you started. 100 plus interesting datasets for statistics, rs.io Datasets Archive R datasets. Another technique, and my technique, was to find a deep problem, predicting the stock market, that could still be broken down into small, implementable steps. I first connected to the Yahoo Finance API, and pulled down daily price data. I then created some indicators, like average price over the past few days, and used them to predict the future. Note, no real algorithms here, just technical analysis. This didn't work so well, so I learned some statistics, and then used linear regression. Then I connected to another API, scraped minute-by-minute data, and stored it in a SQL database. And so on, until the algorithm worked well. The great thing about this is that I had context for my learning. I didn't just learn SQL syntax, I used it to store price data, and thus learned 10x as much as I would have by just studying syntax. Learning without application isn't going to be retained very well, and won't prepare you to do actual data science work. 3. Learn to communicate insights. Data scientists constantly need to present the results of their analysis to others. Skill at doing this can be the difference between an okay and a great data scientist. Part of communicating insights is understanding the topic and theory well. Another part is understanding how to clearly organize your results. The final piece is being able to explain your analysis clearly. It's hard to get good at communicating complex concepts effectively, but here are some things you should try. Start a blog. Post the results of your data analysis. Try to teach your less tech-savvy friends and family about data science concepts. It's amazing how much teaching can help you understand concepts. Try to speak at meetups. Use GitHub to host all your analysis. Get active on communities like Quora, DataTao, and R Machine Learning. 4. Learn from peers. It's amazing how much you can learn from working with others. In data science, teamwork can also be very important in a job setting. Some ideas here. Find people to work with at meetups. Contribute to open source packages. Message people who write interesting data analysis blogs, seeing if you can collaborate. Try out Kaggle and see if you can find a teammate. 5. Constantly increase the degree of difficulty. Are you completely comfortable with the project you're working on? Was the last time you used a new concept a week ago? It's time to work on something more difficult. Data science is a steep mountain to climb, and if you stop climbing, it's easy to never make it. If you find yourself getting too comfortable, here are some ideas. Work with a larger dataset. Learn to use Spark. See if you can make your algorithm faster. How would you scale your algorithm to multiple processors? Can you do it? Try to teach a novice to do the same things you're doing now. The bottom line. This is less a roadmap of exactly what to do than it is a rough set of guidelines to follow as you learn data science. If you do all of these things well, you'll find that you're naturally developing data science expertise. I generally dislike the "here's a big list of stuff" approach, because it makes it extremely hard to figure out what to do next. I've seen a lot of people give up learning when confronted with a giant list of textbooks and MOOCs. I personally believe that anyone can learn data science if they approach it with the right frame of mind. I'm also the founder of DataQuest.io, a site that helps you learn data science in your browser. It encapsulates a lot of the ideas discussed in this post to create a better learning experience. You learn by analyzing interesting datasets like CIA documents and NBA player stats. It's not a problem if you don't know how to code. We teach you Python. We teach Python because it's the most beginner-friendly language, is used in a lot of production data science work, and can be used for a variety of applications.